Welcome to this week's Center Math Problem of the Week. For this week's problem, we're given two integers x and y such that 1978 to the x has the same last three digits as 1978 to the y, and we want to find the minimum possible value of x plus y. So first, some preliminary observations. Our problem is one of the statements is equivalent to saying 1978 to the x is congruent to 1978 to the y mod 1000. Note also negative 22 is congruent to 1978 mod 1000. And so we can rewrite our problem as negative 22 to the x is congruent to negative 22 to the y. Note that if this is equivalent to minus 22 to the x times minus 22 to the y minus x minus 1 is divisible by 1000. And so note this inside part can't be divisible by 2, so our outside must be divisible by 2. And so 1000 is 2 to the 3 times 5 to the 3, so x must be greater than or equal to 3. So saying x is greater than or equal to 3, we can take out 2 to the 3 here. We can ignore this part because it doesn't have any factors of 5 in it. And so we want negative 22 to the m, saying m equals y minus x, congruent to 1 mod 125. We can also note that m must equal 4 times b, because negative 22 to the 4 is divisible by, is congruent to 1 mod 5, and no lower power is congruent to 1 mod 5. So raising the powers, we see it cycles every 4, and so we want m to equal 4 times b. So we have negative 22 to the 4b is congruent to 1 mod 125. And we can note that negative 22 to the 4 is actually congruent to 256, which is congruent to 6 mod 125. So plugging that in, we have 6 to the b, which is equal to 5 plus 1 to the b, has to be congruent to 1 mod 125. So expanding 5 plus 1 to the b and ignoring powers higher than 5 cubed, because those are clearly divisible by 125, we have b times b minus 1 over 2 times 5 squared plus b times 5 plus 1 is congruent to 1. Doing a little simplification, we can write that as b times b minus 1 over 2 times 5 plus 1 is congruent to 0 mod 25. And so this would imply, because the inside cannot be divisible by 5, that b must be of the form 25 times k. And so putting this back in, so we have y minus x must be 100 times k, but we want to minimize y minus x, so plugging in k equals 1. We have y minus x equals 100. Note that 100, given Euler's-Toshin theorem, using that, we see 100 actually works here. So y minus x, we set that equal to 100, x equals 3. And so we have x equals 3, y equals 103, and x plus y equals 106, which solves our problem. Thanks for watching. Check out centermath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.